Okay, so welcome to the second video of setting up the StrangeBrew Elsinore web interface. This one I'm going to talk over because it's a little bit more to do. So this is the default screen you get when you access the IP address or the host name of your Raspberry Pi or BeagleBone Black and put /controller in it. This is a straightforward web interface. It's not too complicated technically. It works on mobile devices like Android. Oh, because it's a web browser, it works on anything that's got a web browser. It's been tested on Safari, Chrome, Firefox, Internet Explorer. Everything appears to be working. So now we have the top left hand side of the screen up here, we've got the Elsinore logo or name, and then StrangeBrew Elsinore, which will take you to the GitHub website. And this is by default set up in edit mode on your first run. Edit mode has more buttons around and more things you can do. When it's locked down, then you can't edit anything and it's a lot cleaner. So starting from the top left, you can double click on the brewery name and you can call it something. So I'm going to call mine Dughead Brewing. And there we go. Now the brewery will remember that. When you shut down and start up again, you've got a name. You can change the icon for your brewery. Click on choose file and upload a new one. There are a few presets that you can use from the launch to set preset icons and brewery logos. Then on the at the top again, we've got the lock button. Double clicking on these buttons will lock the screen down. You can see it's a lot cleaner, but obviously it's not set up yet. And double clicking on edit again opens it up again. By default, Elsinore is in Fahrenheit mode. Double clicking on change temperature scale will convert us over to Celsius, and it gets rid of the extra precision point as well. And double clicking again takes us back to Fahrenheit. Because I'm in North America and I'm used to it, I'm using Fahrenheit for this. I use Celsius for temperature for weather. It's confusing. Don't worry about it. So now we're in edit mode. And on the left hand side, we have what are called the temperature probes. And these are all one wire addresses. 28 denotes the device type, which 28 is temperature. And then down the bottom, we have system as well. Now, the system temperature is optional. You don't have to have it, but it will tell you what your BeagleBone or your Raspberry Pi is running at. Double clicking on it will turn it on, reload, and now we have the system temperature. In a BeagleBone, I think it's a not very changeable number, so this normally sticks at 220, and I don't normally use it for that reason. So I double click it again, and now it's gone again. So up the top here on the left hand side, we've got the free addresses. Now I already know what my probes are because I've done this a few times. But when you plug the devices in, it should automatically refresh this after a couple of seconds, or you'll be able to refresh the page after a couple of seconds and you'll see the new probe added. And then you can set that one up, add your second probe, double click it again, and then so on and so forth. Now my brewery is actually in my garage, and I'm in my living room very comfortably right now, and it's really warm outside and I don't really want to be running in and out. So everything here is set up to begin with. Now I'm going to start off with the temperatures because these are easy. Now I know that the top one here is my MLT, so I'm going to double click on this. Now you can delete all of these. Well, not the top one. You can delete these though, and they'll tell you what the inputs are. The first one is a name, so I'm going to call this MLT. The second is a GPIO and the aux GPIO. Now the GPIO is if you want to set up a PID, then you put your GPIO in here in the order that's provided, GPIO underscore 0 underscore 1 or GPIO 0 underscore 1, depending on your setup. Now, for multiple banks, you'll be able to look at your BeagleBone or your Raspberry Pi, work out what pins you want. Now, that will be your GPIO that's used for PID control. When it needs to turn on, it will turn on that pin. When it needs to turn off, it will turn off that pin. The aux GPIO is a manual secondary element. I don't use this personally, but other people do, and that will provide a straightforward on-off button for the auxiliary. The cutoff temperature is a safety precaution which I have. Now for my MLT and my kettle, I don't use it, but for my SSR temperature, I have it set. And what happens there is that when the temperature probe goes above that value, it will turn off the system entirely. And it will turn off all the GPIO outputs. This is a safety feature so that it doesn't blow up. I have had fire happen from an SSR shorting, and I've kind of got a little bit cautious as a result. The calibration offset is if you notice that one of your temperature probes is off by, say, 1 degree Celsius when you're setting them up, you can set in 1C or minus 1C if it's 1C above, and then it will add that onto the temperature that's added in, that it reads, and then that's going to be your actual temperature. Now, the cutoff temperature using minus 999 will turn it off, and for these I'm using that. Anything other than 199 is going to be used. I know that I should probably change that to something, but with the fact that this is designed to be able to support heating and cooling for fermentation chambers, I wanted to make it a very obvious value. The calibration offset I don't need for mine, so this is going to be my MOT. Press update. And then this one, they've moved around a bit because order-wise 2's come before letters. So now I'm left with 2 that are uncalibrated, that are undefined. So here I'm going to call this one my SSR heat sinks. As I say, this is my safety one. So I'm going to set this up to 185 Fahrenheit. So when it goes over 185 Fahrenheit, the system will turn off, and that's the safety temperature. That's the safe operating temperature for my SSRs. I've never seen these ones go that high, but I've had some in the past, as I say, that have. And now I'm left with 2, and this one is my kettle. Now, my kettle will have a GPIO, and because I'm on BeagleBone Black, and I've already had my device tree overlay exported with GPIO 0_7, I'm going to use GPIO 0_7. As you can see, I don't have an auxiliary GPIO, I don't have a calibration offset, and I don't have a safety temperature, so I'm going to press update. Now, you'll see that things have moved around a little bit. We've got PIDs on the left-hand side, and these are in individual units, so if you have multiple PIDs, they are next to each other in parallel, and the temperature probes are always a vertical line. So this is still in edit mode, and on the PID I can now add in mash steps. So if I want to have, for instance, a mash profile set up, I can either do it from StrangeBrew Java and send it over to StrangeBrew Elsinore, or I can add it in manually through the web interface. So here I'm going to add in a step, and this is the target temperature, so let's say 154 Fahrenheit is my unit. You don't have to set step method or step type, it's just there for you to use as a mental thing. And then we have a duration time, so this is in minutes. So let's say I want to have a 30-minute hold at 154, so add this one in, and then say I want to drop it down or increase it, say, to 158 Fahrenheit for 15 minutes. Now, I know many of you will look at me and say, well, that doesn't make any sense. Why would you have those two? And yes, I also know there is a little bit of a bug here which I need to fix. So it's because I pressed add too many times. So if I do 100, confused myself. Go back in here, add 158, and keep that for 15 minutes, and then press add. The parent's broken it. Or not. I don't know what's going on quite yet. There we go. 158 Fahrenheit. Just me being a little bit slow and not pressing the button correctly. So now I don't want to add any more steps, so I can hit cancel. And we're still in edit mode. Nothing's changed yet. And now I've got mash step set up. They won't activate unless the PID is set in automatic mode and is on. If you have it in manual or hysteria and you press activate on the mash steps, it won't do anything. So now there's no more editing really that I need to do, But what I'm going to show you is if you want to add in volume settings, if you double click on where it says no volume, there's two ways to do this. I'm using the brew controller method of volume reading, which has been approved by the person who actually designed that part of the system. What it works off is the pressure difference. There are links in the documentation that explain how to do this and how to set it up. But if you're on BeagleBone Black, or if there is a Raspberry Pi in the future which has a direct analog pin access, you can set your analog pin number. Now on BeagleBone Black, these are set to 1.8 volts maximum, so you don't want to have anything over 1.8 volts being attached to it, which is why I have DS2450 set up. DS2450s run off the one wire bus, and they have 4 analog inputs that can run over one bus. It's great. I can use it for pH sensing, which is coming soon, and volume sensing for multiple vessels. So you'd either add in your, whichever one you're using, if it's just the pin or the address and the offset of the DS2450, and then the amount of volume you've added in, and the unit. So the unit by default is liters, there's no conversion. And then when you hit update, you'll be able to add in more volume things. So you can add in, say, 1 gallon, type in 1 here, and then type in gallon in this box, hit update. Then you can do another one, and you can say add another 2 gallon, another gallon in, press 2, and what it will do is it will, every time you add it in, it will take 5 readings at 200 millisecond intervals just to account for any slosh, and then average that out to be your pressure at 2 gallons, or 1 gallon, or 20 gallons, or 1 hectoliter, whatever you want to use. Let's just cancel that for now, as I say I'm not going to use it. So that's all the setup stuff for the PIDs. What we also have, and I've got to fix this a little bit because the logo is covering it, you have pumps and timers that we can add in. So if you want to add a new pump, you just give it a name and a GPIO output. So let's say pump A for demonstration, GPIO 08. It's not in use, it won't do anything, but it's there. So pressing add, now I have a button I can turn on and off the pumps. Obviously this isn't doing anything at the moment, it's just explaining what you can do. You can add in as many of these as you want, you just get new buttons for every single one. Then we have timers. Now timers at the moment are very simple, very basic, in terms of you just have a name. So for instance, mash, or if say you want to add in one that's called, I don't know, thinking my brain here, boil. So now I've got 2 timers here, and I'll show you how we can use those in a second when I can actually use a slightly cleaner UI. What I'll do for now though is also show you how you can delete things. This works the same for everything, or anything that's added in for pumps, timers, and mash steps. For mash steps, if you click on one and drag it to the delete button, it will delete it, and you can do the same that. You can also reorder using this. Oh, I did too quickly. You can also reorder with this as well. So for instance, I can move this one down to here, and now they're going to be reordered. There's a little bit of an error message there as well that you can see. Clear that. And then for pump, drag that down onto the delete pump, and then you can use it again. So now if I double click on the lock button, you can see that it's cleaned up the interface. The mash steps are still there, the timers are still there, but the pumps have gone. And now if I try and double click up here, nothing will happen. So for the timers, you can press start, they'll start counting up. It takes a couple of seconds. If you click on the number again, it will pause it, and then you can start it again, pause it, and then you can hit reset, which takes a couple of seconds, and there's a bug there. There we go. Okay, I'll have to look at that one. There we go, just had to clear it a couple of times. So now that's done, you've also got temperature graphs that you can look at. So clicking on a show graph for each of these it takes a couple of seconds to load this data from the server, but we have the duty percentage and the temperature for the PID, and we just have the temperature for the temperature probes. If you click on it, it will take you through to the full set of live data for the vessel you've selected. And then you can do, say, view all inputs, and that will bring all of the actual temperature readings that are being used by the system, and you'll be able to see them. So you can see here it's a little bit confusing because of the fact that we renamed things during this run. There's a little bit of older information there which says, say, the actual old temperature probe names, and obviously that's not correct for what we're looking at, but it's correct at the time. We don't map them back. It's very simple. If you restart Elsinore, then those old ones will go away and it'll only work on the new ones. So get rid of that. And now I can show you how we use the PID mode. So there's 4 different modes. You've got automatic, which is your standard PID controller configuration. There's hysteria, which will activate the heat output when it goes below a certain value and turn it off when it goes above a certain value. We have manual, where you set the manual duty cycle percentage and a time, and then off. So for auto, standard PID settings, the set point is what we want the temperature to be. These will default to 0, so let's say we want to get to, let's say, 164 Fahrenheit. The duty time is 10 seconds. That means that if the duty percentage is 50, it will take 5 seconds on and 5 seconds off. It's how long each duty cycle is this time frame. Then we have the proportional, integral, and differential values. I believe they are the PID values. Most people will only need to use P and I, and this will require some tuning. Set the values of P to make sure you can raise up, and then it fluctuates around your target temperature. I can be used to fine tune that so it doesn't overshoot. And then D really is not used that much, as I say, but can be used to increase the accuracy of the temperature output. When you selected the values you want, so for mine I use 60 seconds per Fahrenheit for P, because I've got a really big system. And then now you can see that my duty cycle is set to 100. I'm just going to hide these graphs. So my duty cycle is now set to 100. If I wanted to, I could press activate and it will activate my mash profile, but I don't want to do that right now. Now these values will still show you what it's set to, but they're grayed out. You can't actually go in here and start changing them around. This is just to make it a little bit easier to use. So now if you want to unlock these, you can hit auto again, and then they're unlocked. You can now start changing these values, update the values that are being sent to the server, and everyone's happy. So next we have hysteria mode. So here we have the minimum and maximum temperatures. If you convert the scale of the Elsinore itself, these F's will change to C's, obviously. And then the time is what the minimum amount of time is before it will turn back on. This is the same thing that you would use with a STC 1000 or Johnson temperature controller with your keg fridge or your Keyser. It just prevents anything from burning out. This is normally used for if you say we had a fridge attached to this and you wanted to cool down, then you could just use that as well. But this was actually specifically added in to control gas outputs. And the time is just a safety time. So normally you want to look at your instructions, make sure you understand what the maximum amount of time is that it has to be, or the minimum amount of time that has to be off between turning on, off and on again, or on and off again, whichever way around you want it to be. Generally it's both. So manual is duty cycle percentage and the duty time. So you can see here it's picked up the duty time that I set in auto, and the duty cycle is 0 because that's what it was previous. That's what I manually set it to. So now if I set that to say 67% and press send command, give it a second, and you'll now see that the cycle has gone down to 67. And again, values are locked. And then to turn everything off, you just hit off and send command, and there we go. So this is a very brief overview of Elsinore. I found a couple of bugs. I'm going to go away and fix those now. But this just shows you the basic output and the basic controls that you can use. This is all usable from your mobile devices, your tablets, your laptops, anything that's connected to the network. Obviously, think about safety here. Don't leave something unattended that's got electricity running through it or gas running through it. That's just not safe. Make sure that you have all your safety precautions set up. Don't leave your elements running in a dry kettle. Make sure you have a safety switch. Make sure that you have a GFCI output. This is not a we're going to protect you for everything. This is just a very simple project which I did for myself because I wanted the experience and the knowledge of writing something like this. Thank you for your time and good luck with Elsinore.